طيب بسم الله الرحمن الرحيم. So last time the slides were corrupted a little bit, so I fixed that. So we started talking about IPsec. We talked about IPsec having like an umbrella of specifications, one for ESP, for AH, for IKE, and we'll talk about the details of this. So we just started by talking about certain scenarios where IPsec can be used for. We talked about scenarios like securing branch offices. We talked about the fact that we can have two offices in two geographical locations, and we can have IPsec to provide like a secure tunnel, okay, to secure the communication between these two offices over a public network. We talked about this last time. We can use IPsec to secure remote access over the internet. So we can have like a host, and then over the internet, a host مثلا remote host. You can take your laptop مثلا outside in a hotel, and then you want to connect to the company's or the organization network. So if you can have a secure tunnel using IPsec, you can access the internal servers inside your organization through this tunnel. Or establish extranet and intranet. We talked about this, and we have again, we have one office, one private network, مثلا اللي هي Microsoft 1 و Microsoft 2, and these are two offices, يعني two private networks, and in the middle we have the internet, and the internet is a public network. So we can implement IPsec on one router here and one router here, and implement some kind of IPsec tunnel to provide secure communication between these two offices over the internet, over the public internet. So these can be two offices of the same organization, in which case it's a intranet, صح? We talked about this in network 1. Or two offices of two different companies, in which case it's a سميها يا محمد. ايوه. Between two organizations سميناها ايه؟ اكسترا. ما انت مش معانا، ما انت عمال تشتغل عشان كده. اكسترا نت، اوكي. ففي الحالتين يعني we can use IPsec using بقى VPN ولا كده. You establish a VPN tunnel between the two offices over the public internet. IPsec is an excellent يعني standard for this. Or enhancing electronic commerce security. What does that mean? Electronic commerce عارفين اللي هي زي سنونو زي Amazon كده يعني. How can we? It's not here when we talk about electronic commerce system. Electronic commerce system. It's not just a website. It's actually a full ecosystem of supply chain management, and you have to deal with suppliers and stuff. So it's actually there is some extranet in the back end of the e-commerce system that allows the e-commerce system to or the e-commerce server to communicate with suppliers here and there. So you can also use IPsec to communicate securely with all the suppliers, with all the delivery companies, with يعني it's a full ecosystem يعني صح؟ it's not about securing the web server itself, because web server securing web server we can use TLS, but here we're talking about communicating through a big network in the back end of that e-commerce system, okay, with the suppliers and so on. Okay, so anyway, so of course the main principles of IPsec again is to provide the main pillars of security, like اللي هي encryption. Okay, and of course we have to do integrity, and of course we have to do authentication. After authentication, قلنا authentication is a prerequisite. خليك معنا محمد. Authentication is a prerequisite to key management, صح؟ Okay. And of course, for key management and for creating bunch of keys, for key management we can establish اللي هو الماستر key, and then we need to establish some keys. فعندنا برضو اللي هي ايه بنسميها pseudo random function generation اللي هي بقى we can create بقى IVs, we can create session keys and so on. Okay, so we need to do all these functions using برضو IPsec. Actually any standards they have to be able to implement all these functions. صح? It's just in what level we have to implement these functions, whether it's transport or whether it's device to device in the case device to device in the case of network access layer, or in the application layer we use tickets, or in the transport layer we use TLS. Okay, but in all cases we have to do all these functions. Okay, whether it's application to application, or network to network, or host to host, or device to device. Okay. هو ده طبعا ميكس صح انت عندك حق يعني هي this is a mix between the provided service or the function itself. The encryption provides confidentiality صح. Integrity, we talked about integrity through digital signatures. Okay. Authentication is here I refer to message authentication, which is used for authenticating every single message صح. And we have to use like some key management in terms of generating a master key, generating session keys, and generating IV, which allows us to generate some dynamic keys and so on. طيب, we talked about these scenarios, and IPsec provides flexibility in terms of securing private network to private network communication using tunnels.
So Victor,
confidentiality, yes.
It's not included in
هو encryption provides
all the
for everything. يعني encryption عامة provides confidentiality. Encryption and decryption is used for confidentiality. Integrity is about يعني here we talked about securing private network to private network communication through establishing a tunnel between routers or between firewalls, right? We talked about this, which is what we call a tunneled mode. We'll talk about this today again. Or you can have a tunnel between a host and a network, or between a host and a host, which aligns with the main function of the network layer. Main function of the network layer is to provide host-to-host communication or network-to-network communication, right? So IPsec also provides tunnels between a host and a network, or a host and a host, or a network and a network. So the advantage if you implement IPsec in the router or the firewall, so this way we don't have to implement IPsec on the actual hosts. صح؟ خلاص, all the traffic from this network is secured through IPsec on this firewall. خلاص. We don't have to implement IPsec, because IPsec is heavy, as we said. IPsec is very heavy. So if we do IPsec at the router level, and we can do this at home. يعني at home, if you open up your router configuration, one of the configuration is to have VPN at the router level. In which case, خلاص, all the traffic from your house is secured through this VPN. خلاص. Even if someone in the house does not want that, but all the traffic خلاص, it has to go through the router, which means it's all secure. Okay. Or you don't have to do it at the router level, in which case you have to do it at the host level. But if you want to do it at the router level, then اتكلمنا بقى على ان هنا we have to do some two headers. One is the inner header, which is the original IP address, and here is in the original IP address, a host would specify the original host of the other on the other end. However, we have to do tunneled mode, in which case we have to provide another outer IP header. And in this outer IP header, we refer to the IP of the not at the final destination. We refer to the IP header of the firewall on the other end, at the end of the tunnel. Yeah. So that's why we need to have two IP headers in that case. So we call this a tunneled mode. Okay, we'll talk about this again today. This firewall or this router will have to apply certain policies. The traffic that is coming in it has to decide whether it has to go through the tunnel or it goes through the public internet. Okay? This is based on some policy database that exists here. Okay? So the policy database specifies some rules, we'll talk about this in details, some rules based on which either you route the traffic through the tunnel or you route the traffic away from the tunnel, which means that it goes to the public internet. And one common example, we talked about it last time, is the way if the incoming traffic does not have to go through the tunnel, yeah, but what is a common example that the traffic that it's coming in, we don't really have to route it through the tunnel. We talked about an example last time that if the traffic that is coming in uses TLS, okay? So this means yes, because what we are afraid is that we have some application here that uses UDP without really using any kind of security. This application on this host can be used to inject some routing messages to the infrastructure, damaging the entire infrastructure. صح? So we have to make sure that it's secure. So here, this firewall will apply certain rules. So if we have an application here that uses TLS or SSL, so in that case, this application is by default secure. So you don't have, in that case, you may decide not to repeat the work. خلاص, the traffic is coming and it's already encrypted. You don't have to provide another layer of encryption. خلاص, so you may actually bypass this and let it go through the internet because it's already secure, and it's also TLS provides some kind of tunneling, but in the transport layer. And this tunnel is application to application, not host to host, not network to network. But at the end of the day, it provides some kind of a logical tunnel برضو. So we don't have to have a tunnel inside the tunnel. يعني you may decide, خلاص, if the traffic is coming secure already, you don't have to route it through the VPN tunnel.
Is the data transmitted, does it have tag saying, hey, I'm encrypted?
Yes, of course, it's in the header.
Right.
It's in the header. Everything is in the header, so you should be able to and we do this from the TCP header. Because TLS does not, as we said last time, TLS does not encrypt the TCP header. صح? So I should have access to the TCP header. So I can... Yes, it's the data inside it that's secure. Right? So if you know that from the TCP header that already خلاص, I'm using TLS, and of course because the TLS header is after the TCP header. Right? And it's exposed. It has to say at least that the payload has some kind of TLS message that's encrypted and you cannot see anything inside it. So you can recognize that this uses TLS. Okay? And from the TCP header you get the port number, صح? And of course you get and you get the service. And you know many things from the TCP header and the TLS header, so you can decide based on that خلاص, if it's TCP and TLS, خلاص, you don't have to encrypt it again and provide another tunneling. Yeah. Okay.
Can the stuff not be modified, like the header, the contents of the header? Is it not
modified?
Can it be modified?
You mean like if there is attack or something?
Yeah, like. If I want to claim this is a secure package, I'll tell it it's TLS, and then it will allow through, but it's not secure.
How is it not secure then?
Like, I'm claiming it's TLS, but it's not actually protected by TLS.
You try to modify that. You could, yeah, it could, but this means that some host here is compromised. But our assumption is this is a private network. A private network معناها internal, and we trust this network, right? So if we trust this network, this means that the applications inside it should be trusted. Okay. So these are the benefits. We talked about this last time. يعني if we do IPsec implementation, as we said, in the router level, خلاص, all the hosts in this private network will use that tunnel. Also, IPsec can provide اللي احنا سميناها ايه policies. So just the fact that you have a tunnel, it doesn't mean that all the traffic has to go through that tunnel. No. So these are the benefits. So if IPsec is below the transport layer, this is what we have been talking about. All the applications خلاص are transparent. They use the IPsec tunnel. Either they want to do this or they don't want to do this. خلاص, everything is going to use the tunnel no matter what. So IPsec can be transparent to the end user as well. And this is good because you don't have to train users that if you want to access QU network, you need to use VPN. يقول لك إيه VPN? I don't know what VPN is. So if IPsec is implemented in the router, خلاص, you don't have to train the user. خلاص. You don't have to learn about the VPN. خلاص. All the traffic that you are sending will go through the tunnel anyway, so you don't have to know about it. ماشي? So IPsec can provide security for individual users if needed. So you can actually configure the policy database that if the user is external to the organization, you have to get his traffic through the tunnel. If the user is like internal, then the security level can be reduced or something like this. So it depends on the traffic that he's using. If he's using WhatsApp, or if he's using some internal service in the university, if he's using مثلا e-learning platform, Blackboard or something. So if the user is internal and using مثلا Blackboard, which is internal service, then خلاص, يعني the traffic is trusted already, so you don't have to provide more overhead.
Can it depend on the IP of the country?
Yes, of course. Definitely. You can, the policy database, we'll talk about this in details later on. We call it selectors. It can be a combination of username, IP address, port number, anything. Okay? And can be or, can be wildcard, anything. We'll talk about this. Type. So we talked about these different types of messages that IPsec secures. It was corrupted last time, يعني. But here we talked about the route advertisement, route update. We talked about اللي هي neighbor discovery and neighbor solicitation, which is part of IPsec version 6, if you remember from network 1, يعني. So these are routing level messages that it goes through the tunnel and it's secure. So or redirect in the case of NAT also. So all the messages that are in the routing level or above the routing level, like ICMP messages, all of these they can go through the tunnel, and in that case they are secure, and so you guarantee that there is no network injection or something like this because it goes through the tunnel, so it has to be secure. This is these are subset of the specification documents, subset only of the specification documents of IPsec. So you have, of course, the overview of IPsec architecture, which shows best the different components without providing any details about each component. So this is laid out or detailed in RFC 4000 something. You don't have to memorize these numbers. But this is like an architecture description, which is going to come in the next slide. The two major ingredients as part of this standard are AH and ESP. ESP stands for Encapsulating Security Payload, and this is used mainly for establishing this tunnel in terms of encryption. Okay? Tunnel معناه ان everything inside that tunnel is encrypted and it's hidden, right? So this is to establish that tunnel. AH is used for authentication. Okay, and here we mean like message authentication back. Okay, so this part of the standard is responsible for authentication. Something a little bit, I don't want to get confused here, because in IPsec version 1, those two components were separate. So there's ESP for IPsec version 1, and there is AH, and they are totally separate. حتى even the headers are separate. You have ESP header, you have AH header, right? And these are separate, two separate headers. And IPsec version 1 separated these two completely. IP version 2, they have actually combined the AH functionality into ESP, okay? So ESP would do the encryption and the authentication both at the same time. But that doesn't mean that the AH as a standard, it has been removed from IPsec version 2. Why? For backward compatibility. So they left so they left AH as optional. Okay? But they tried to deprecate it. But in IPsec version 2, you may actually, if you look at the message, you may find only ESP header best. Only. ESP header only. You may not find AH, because AH is optional as part of IPsec version 2. واضحة دي? Okay? Which means that ESP would do the encryption and the authentication both at the same time.
Authentication did the same message authentication code.
Yeah?
Same like the message authentication code.
What is this?
The authentication header.
Yes. Authentication header, yes. Well, authentication header is where we put the message authentication codes. Exactly, yes. So it's actually AH provides the digital signature that's encrypted, اللي هي المسج authentication code. Okay? طيب, so these are the two main ingredients of IPsec, and here we have بقى IKE or Internet Key Exchange. This is responsible for key management. Okay? This is responsible for key management, and the key management, it establishes what we call security association. We'll talk about this. It creates IKE creates the security association. Security association provides all the keys and parameters for the tunnel, or the keys and parameters, and of course it stores also the mechanism that you use for encryption, mechanism that you use for authentication, the mechanism that you use for pseudo-random function, all the mechanisms that you use are stored in something called security association. Okay? So security association provides a full context of what keys and what techniques are used in this session or for this tunnel. Right? So based on these parameters, ESP will perform encryption, right? And AH will perform the MAC. ماشي كده? So this security association is one of the most important components in IPsec, and we'll study it in details. The cryptographic algorithm, this provides the specifications for all the possible techniques that can be used for encryption, for authentication, for MAC, for this one lays out or details مثلا this is HMAC SHA1 and this is how it works. This is this uses encryption using RSA and this is how it works, something like that. Okay, so this is a applied cryptography course, which is not our main focus. And there are others, and in the others document they also describe the policy rules that IPsec can use. اللي هي بيسموها selectors and so on, which is what we are going to see later on, maybe next time. So this is very important, the difference between transport mode and the tunnel mode. Okay, so transport mode first is used typically to establish a tunnel between two hosts, or mainly two hosts, one host, and you establish a tunnel, which means that this tunnel will go back through all the network infrastructure, including routers and firewalls, and okay. So it's a host to host. So the original destination is the tunnel destination. صح? You have you have one private network here and then another network here. Of course, here you have the router, and here you have a router. So you have a host, and you have a host, right? So if you establish the tunnel this way, okay, so the destination IP address of the tunnel is the destination IP address of the other host that you're trying to communicate with, right? So that's why the original header is the same. So you would see that you have the payload, right? And then you have the original IP. This is the IP header, okay? And then you add after this the ASP and optionally the AH header. If it's IPsec version 2, then it's only ASP header and AH may not exist. ماشي كده؟ خلاص. So that's it. And then you put back all the TCP header and everything. خلاص. ماشي? So this is we call this transport mode. So in that case, the destination of the tunnel is the destination host. It aligns. ماشي?
So it's secure even for the NAT.
Right. So this tunnel goes through all the network infrastructure. خلاص. Goes through the network infrastructure. This is typically used if you are trying to access a server and you can establish a tunnel between you directly and that server, and then all the IPsec functionality will be done by the host, which means it's heavy, it's a bit heavy, and it may cause you some slow performance sometimes. ماشي? So this is the transport mode. In the tunnel mode, you don't do this. What you do is that you have to have the payload, okay, and then you have the original IP header, okay, but then the tunnel in that case is established between this router and this router, ماشي? Or between a host and a router, ماشي? So in that case, if this host still wants to communicate with this host, ماشي? So the original header here maintains the source IP and the destination IP. When it goes through this, now you are entering the tunnel and you're getting outside the tunnel. So in that case, the source IP address is the IP address of the router port, and the destination IP address is the destination address or the port IP address of the router at the end of the tunnel. So in that case, you have to have ESP and again optionally AH, okay? But then you have to add a outer IP header, ماشي? Different from the original IP header. So this is called the tunnel. And here, of course, when you do encryption for this entire, actually, command, there is a part here. We'll talk about it. It's called ESP trailer. We'll talk about it later. ماشي? So you do encryption for the entire payload, but not the IP header, because this is transport mode. For the transport mode, you don't do the encryption for the header. Why? Because the routers, the intermediate routers, they need to be able to see that original header to do the routing. ماشي? So the encryption is done for the entire payload, but not the IP header. So here, you do the entire encryption of the payload and the original header, right? Because you don't do the routing based on this header. You do the routing based on the IP address of the destination router at the end of the tunnel, right? So you leave this exposed, and the encryption is done to the entire payload and the original header. You need to hide this completely until you get outside of the tunnel. ماشي? So this is the main difference between the tunnel mode and the transport mode. And the tunnel mode is good for securing host to host. The transport mode is good for securing host to host communication, tunnel mode is for network to network or host to network. Because in all cases, the final or the destination IP is not the final IP of the host. It's actually the IP of the end router at the end of the tunnel. ماشي كده? So this is the difference between the two. The standard provides ultimate flexibility, by the way, that both ASP and or AH can be used for transport mode or for the tunnel mode. And in fact, we'll see at the end of this chapter, will become a little bit confusing. You can have ESP in the tunnel mode and AH in the transport mode, or the other way around. Okay, so you can have this header and or this header before or after the original header or the outer header. The standard provides ultimate flexibility.
For tunnel mode, as soon as it's gone to the other side,
Right.
the IP
خلاص, it will get decrypted and everything will be exposed, because again, the assumption here, the assumption here is that this network and this network are private networks and they are secure, they are trusted.
Right.
Once it comes at the end of the tunnel, everything will be decrypted and the job of IPsec will be done. خلاص, from then on. And that's why actually we sometimes use this to, so this is what actually the VPN service providers do. They provide some servers at certain locations, okay, so that you can just bypass your service provider through the tunnel. Once it gets to this server, everything will be decrypted, and from then you can get back to any website, whether you want to buy something illegal or want to access servers that are not accessible, مثلا from your country, or you can do whatever. Okay.
This is all dependent on the trust of the private network. And if there's more than one host, and it's just decrypted and sent to once it reaches the other.
Of course, because once you decrypt, معناها إيه؟ خلاص, this part is out, and you go back to the original IP, and the original IP has the final destination.
Yeah, but the payload is decrypted as well.
Well, payload is decrypted. خلاص, ما أنت once you get rid of this, معناها the payload will be decrypted based on the information in the ASP and AH, right? And about based on that doesn't mean that the key is not stored. Of course, the key is not stored. We'll talk about how we get the key from the information inside the ESP. But of course, the key is not stored in the. Do not ever think that the key is stored inside the ASP header and this is not. Okay, I will see how this is done. But from this information, somehow you can get to the key and decrypt at the end of the tunnel. Okay. And at the end of the tunnel, everything will be decrypted, and you go back to the original IP, and you do standard IP stuff. Everything is decrypted. You go back to network 1, everything decrypted, وخلاص. My job is done.
What type of algorithm is used for encryption?
There are possibilities بقى. ممكن RSA. It depends. We'll see. It depends. We'll talk about this in details later on. ما حدش فكرني يا شباب.